Okay, so I'm going to try to get through this as quickly as possible. But we're given a polynomial, this quartic polynomial, and the question is to find all the zeros of the polynomial when given x equals 1 and 4 are zeros of that polynomial. So I'm given 2 of them, and I need to find all the others. Well, because it's a quartic, I know that there's 2 more. There's 4 total. So what I'm going to do is I'm going to use these, and because these are zeros or roots or solutions, what should happen is if I use those with synthetic substitution, my remainder should be 0. So what I'm going to do is I'm going to use -1, and I have 1, -3, -5, +3, and 4. I don't have any missing terms, so this is it. I'm going to bring the 1 down. And I get the remainder of 0. So what I have left is this polynomial. So what I did is I really took this quartic polynomial and divided it by x plus 1. And what I was left with was x to the third minus 4x squared minus x plus 4. And what I can do now is divide that by my other root or 0, x minus 4, and then it will get it down to a quadratic. So what I'm going to do is I'm going to take that second 0 and put 4. So pay attention that these are the numbers that I'm using here because those are the x values. So I have 1, -4, -1, and +4. I'm using these coefficients now, and I'm bringing this one down. Multiply with 4, 0, 0. This was a 1. And 0, and my remainder is 0 again, which it should because it was given to me that that was a 0. So what I have left is now x squared minus 1, and what I can do now is solve this one. And in order to solve this one, I could do it 2 different ways. Set it equal to 0 and solve. Add 1, x squared is equal to 1, take the square root, and I get x is equal to plus or minus 1. It was a positive 1, there's no I, and I get plus or minus 1 as my other 2 solutions. So all of them combined is going to be -1 with the multiplicity of 2, because I have this -1 and this -1, and then I have +1 and +4 are all my roots or zeros. And so for this one, we're going to do the same thing. I'm trying to find all the zeros of the polynomial. I'm given the polynomial, but I'm not given any of the zeros, but I am given the graph. And if you remember, you can find all the real zeros from the graph by where they cross the x-axis. Well, here and here, I'm not going to be able to tell the exact zeros. It does hit 3 times. It's a cubic. What that means is because it's hitting the x-axis 3 times, that all the zeros are real numbers. All the solutions are real. But I do have this one as exact 0. So what you want to do is find, find the exact zeros and use that with the synthetic substitution to get the polynomial down to a quadratic. Once you get it to a quadratic, or to one of those other special cubics or quartics that we can solve, then you can find all the other ones. Well, for this first one, so this is x is equal to -2, and that means I'm going to use -2 in that synthetic substitution, and my coefficients are 2, 3, -4, and -4, and I don't have any missing terms. I'm going to bring this 2 down, multiply it, -4, -1, +2, -2, +4, and 0. And what I'm left with is 2x squared minus x minus 2. And now because I have it set into this quadratic, I can solve it. You can check to see if it can solve by factoring first. My options would be 2x and x. And I would either have -2 and +1. That would be -4 and 1. That's not going to work. Or 1 and -2. That's 2, negative 2. That's not going to work either. Well, if factoring doesn't work, then we can go to the quadratic formula. So I have x equals negative b is going to be positive 1 plus or minus the square root of b squared, which is 1 minus 4 times a times c, all over 2 times a. And so when I finish that, my solution becomes 1 plus or minus square root of 17 all over 4. And if you remember, this is two solutions, the 1 plus square root of 17 over 4 and 1 minus square root of 17 over 4. And that's would give me these two values between 0 and negative 1 and between 1 and 2. There should be 3 total, so this is 2 of them, and the one given, the negative 2 from here, was the third one. Okay, so go ahead and try this one on your own. Notice that it is hitting 3 times, 1, 2, 3. So, but you can only get one exact 0 out of this. If the other zeros are not real, what the polynomial would do would be something like this. And if it did something like this, that would mean there's one real. There's still 2 other solutions or zeros, but they're not going to be real. They're going to have the I. Sorry about that. There is the rest of the polynomial. And I'll give you the answers right after this joke. Did you hear about the compulsive lying sandwich? He was full of baloney. Okay, so the 1, 0 that they give me is 3, so I'm using 3 in the synthetic division. I'm going to bring my 1 down, multiply with 3, that's negative 2, multiply with 3, that's negative 6, negative 1, multiply with 3, that's negative 3, woohoo! And I'm left with x squared minus 2x minus 1. And if I try to do the factoring, I get negative 1 and positive 1. That's not going to add up to negative 2. Pay attention to that. You can't use negative 1 and negative 1 because they multiply to be positive 1. So I have to use quadratic formula. X equals negative b is going to be positive 2 plus or minus the square root of b squared minus 4. A is 1. C is negative 1. All over 2 times 1 is a. And so when I work that out, I get 2 plus or minus 2 square root of 2 over 2, and these 2's will cancel out to be 1's. So I have the 0 that I got from the graph, 3, and the 1 from the quadratic formula, 1 plus or minus the square root of 2. I don't need to write all over 2, so those are my 3 solutions.